All right, number 7. So part A. Expand and simplify m minus 8 times m plus 5. Okay, so this is just your standard double bracket, yeah? So to expand this carefully, all you got to do is multiply term by term, yeah? So here we do m times m times 5, minus 8 times m, and minus 8 times 5. Okay, so when you do this, and let's have a look, we get m times m, which is m squared, m times plus 5, which is plus 5m, minus 8 times m is minus 8m, and then minus 8 times 5 is just minus 4e. Now every time you get to the stage, we always need to simplify the middle two terms, yeah? And if you do it carefully, you realize that 5m take away 8m is just minus 3m. So therefore, our final answer after simplifying is just m squared minus 3m minus 4e. And that's part A done. Now for part B, they want us to factorize fully 5y plus 20y squared. And what they usually mean when they use the word fully is that there's probably 2 steps involved. So let's have a look. Now to factorize comfortably, the best thing to do is to firstly look at the numbers and ask ourselves, what times table do they both go into? Well, we got a 5 and a 20, and they both go into the 5s. So let's divide this by 5. So the way we do it, we pull out the 5, divide both terms by 5, and we're left with a y and a plus 4y squared. Now we ask ourselves again, is there any other terms? Well, we can look at the y terms now. They both have a y involved, so we can divide y from both. So pulling out the y, we've got 5y outside. Dividing each term by y, we're left with a 1 and a plus 4y. And that's it, guys. This is done. All right, part C. Now simplify all of this to the power 0. Well, you don't even need to think. We just have to realize that anything to the power 0 is always 1. Okay, and that's it. D. Solve this equation and show clear algebraic working. Alright, so for these kind of problems, you got a bracket, so always expand the bracket, and you got a fraction, so clear the fraction. Now looking at the left side, I want us to go ahead and multiply out the bracket, so times in this slot by 3, you should get 6x minus 15, and this is going to equal now the right side, which is 9 minus x over 2. And from here, what we should do next is clear the fraction. And when we say clear the fraction, you should try and get rid of the 2. And the opposite of getting rid of this is by multiplying the whole thing by 2. So that clears automatically. When you do that, this is going to go, and now we're going to get 12x minus 30 equals 9 minus x. And that's it. So the fraction is cleared. Now this is just a case of just moving things into the right place. So to solve for x, all you got to do is move all the x terms to one side and the non-x terms to the right. So what I'm going to do, I'm going to move minus x across, and I'm going to move minus 30 to the right. So this is going to move here, and minus x is going to move there. So doing it carefully, if we add x across, we're going to get 13x. If we plus 30 across, we're going to get 9 plus 30, which is 39. And now to solve for x, all we got to do is separate the 13 from the x. And to do that, we've got to divide both sides by 13. So therefore, you're left with x equals 39 over 13, which is just 3. And that's it, guys. All done. Okay, number 8. So on the grid, enlarge the shaded shape, so this one over here, with scale factor half and center 1, 2. Okay, so what this secretly means is that we need to shrink this by half. Okay, that's what scale factor half means. If it said enlarge this by scale factor of 2, this means you got to double it. Now the second point, which is the point 1, 2, this is going to be your center of enlargement. So the point where you're going to be looking to enlarge it from. So let's find 1, 2 for now. So 1, 2 would be 1 and up here 2. So it meets here. So this is kind of like where your eye would be and where you'd be enlarging it from. Alright guys, so what we're going to do now is that we're going to connect the center point here to every single vertex, yeah? So check it out. So what I'll do, I'll connect a straight line here. So for you guys, it's better to use a ruler. And then I'll be doing it for at least, well, 2 of this for now. So from here to here. And basically the main idea is that we're trying to see where the halfway point is. And so we kind of have to estimate it in our minds. So once we do this, let me get my pen. Now I'm going to just look at the distances from here. So if we kind of imagine that we start at 1 and it goes up to a vertex of, what's this, 7. So our halfway point is probably over here, okay? So just go across the line until you can kind of imagine where the halfway point is. Usually it's going to be on an actual fixed point. Same thing here. Imagine this point now. So if the halfway point will probably be around here. Okay, so again, the half the distance from here to here, just like from here to here. Now at this stage, what you want to do, guys, is now connect these two together. Because when you connect these two, you're going to have basically the same shape as this one, but it's now been scaled down by half. So let's have a look. So I'm going to just change this. So connect this point to here. Okay, change the color of my pen, make it red. So yeah, you can kind of see it matches. And then if you look carefully, if we had to just scale this one by half, we got like what, a distance of how many blocks is this? So 2, 4, 6, 8. So we know that it's going to have a distance of half of 8, which is 4. So again, we add another straight line. So insert straight line from here, and you go 4 across, like somewhere over here. Again, make it red, and so on. And then, well, you get the idea now. So once we do this, we now again repeat the rest of the shape. But at this stage, I guess it's quite easy, because all you're gonna do now is you're gonna go down from here, and then you're gonna go straight across. And that's it, guys. You've effectively scaled this by half. So this is the beauty of it. So when you have like a center of enlargement and you got a fixed point, you can kind of guess or strongly estimate where it's going to be. And that's it. And we're done. And if you actually carry this on, by the way, just for the sake of completion, guys, yeah, if you carried on to the next vertex, you'll realize that it actually cuts off perfectly here. And again, if we did another one from here, you'll realize that again, this corner here cuts off perfectly here as well. So yeah, it actually works perfectly. And that's it, guys. This is the end of the question. Okay, number 9, guys. So here is a right angle triangle. Now calculate the length of PQ, which is the long hypotenuse side here, and let's call that X, since we'll be working at that. And then give your answer correct to 3 significant figures. Alright guys, so I made a few notes here. Every time you got a right angle triangle, we're either going to use one or two methods. Either Pythagoras' theorem, if we're only dealing with lengths and no angles. In this case, we will not be using. Or we'll be using trigonometry, or more specifically, SOHCAHTOA. Okay? Now use SOHCAHTOA if there's angles involved with your lengths, and it's a right angle triangle. Now to use SOHCAHTOA, and you're actually given this in the formula sheet above, guys, yeah? All you got to do is firstly label your relevant sides. Now looking at this triangle, the only side that we actually care about is the side on the left and the hypotenuse. Well, if you're looking at the side next to it, this is known as the adjacent, yeah? Why? Because the length opposite the angle of interest is the opposite. So this would have been the opposite. In this case, we don't care about, because we're not solving it. So all we need is the adjacent and the hypotenuse. And then we ask ourselves, out of the 3 options here, which one involves A and H? Well, we can see that Ka involves them. And well, the C part stands for the cos. For the other 2 guys, the S is the sine and the T is the tan. And for Ka, we can write that as an equation, which can be represented as cos of the angle, so cos 63 equals A, which is the adjacent, in this case 24.3, over the hypotenuse X. And that's it, guys. Then all you gotta do now is just literally rearrange your equation. And to rearrange it nicely, what I would do is I'll multiply X across and divide cos 63 across. So you're gonna have something like X equals 24.3 over cos 63. Okay, and then when you put this in the calculator, you should get a simple answer of roughly 53.5 centimeters. And that's it. That's this question done. Alright guys, number 10 now. So the shaded region in the diagram is bounded by 3 lines. The equation of one of the lines is given. Okay, cool. So they actually gave us this line over here. So y equals a third x minus 2. That is so helpful. Write down the 3 inequalities that define the shaded region. Okay, so we basically need to change these equal signs to greater or equal, less than equal signs. Now to do this one comfortably, and my personal tip is to firstly forget the inequalities for a second and try and define the lines, yeah? So let's look at this diagonal line starting from over here. So this line going here. Now every time you have straight lines, always think of the usual equation, which is y equals mx plus c. Well, to find m, which is the gradient, we just need to pick 2 points and then pretty much find its gradient. And then to find the y-intercept, C is just where it hits the y-intercept. So in this case, for the y-intercept, it hits at 4. So immediately we can call this line mx plus 4. Now to get m, let's pick two random points and calculate its gradient, yeah? So what I'll do, I'll just pick, let's say, this one here and this one here. So this is 0, 4, and this one is 2, 2. Now to calculate the gradient is simply the change in the y coordinates over the change in the x coordinates. Well, looking at the change of the y, it's going to be 4 take away 2 over 0 take away 2. Now guys, when you subtract coordinates, always do in the same order. So if you start with the first one, you have to also start with the first one again for the x coordinate. And then working this out, you're going to have 2 over minus 2, which is just minus 1. So the gradient is just minus 1. In that case, our equation is therefore y, so let me write here, y equals minus x plus 4. Or to make it look a bit more fancy, you can plus x across, so it'll be y plus x equals 4. Both is fine. Now at this stage, we need to figure out what kind of inequality to put for each of these things. And, oh yeah, there's also one more line. So you see this vertical line going down. You don't need to worry about a complicated equation. It's just where it hits on the x-axis. Well, carefully, if you look carefully, it hits actually at minus 1. So this line is simply x equals minus 1. Now, let's go ahead and define inequalities, yeah? So to figure this part out, let's start with the y equation here, yeah? So because the shaded region is above the line, and as we look at the y, it seems to be going on the higher end. This means that because it's above, it's going to be greater. So this inequality would be, let's write down here, y is greater than equal a third x minus 2. So this is talking about everything above. Yep, above. Now, as for this line over here, the other diagonal line, well, we can kind of see that it's on the left-hand side. So technically, it's actually below, yeah? So if you're looking on the y-axis, it seems to be going down. If you look on the x, it seems to be shifting to the left. So in both cases, they're going down. So our equation here is just y plus x less than or equal 4. Now, if you're wondering why we're using the equal sign, well, it's because they're using a bolded line. When they use a bolded line, it means you include the values. If they use a dotted line, it means it will just be less than, or in this case, greater than for this equation. Now for the third one, and this vertical line going down, this is just going on the right hand side of this equation. So in other words, it's going to be greater or equal than minus 1. So this would be x greater equal minus 1. And yeah, that's it guys. So make sure you put your 3 inequalities clear and you should get the marks. And that's it. Alright, number 11. Ooh, okay, so this is Reba. So Max invests $6,000 in a savings account for 3 years. The account pays compound interest at a rate of 1.5% per year for the first 2 years. The compound interest rate changes for the third year. Okay, so key note, we can see in the first 2 years, the rate is fixed at 1.5%, but for the third year, it's different. Now, at the end of the 3 years, there is a total of $6,311.16 in the account. Work out the compound interest rate for the third year. Give your answer correct to 1 dp. Okay, cool. So to work this out, we always use the standard OV-NV formula, which is like this. We say that the original value, which is multiplied by some multiplier, 1 plus a rate, for some number of years, should equal the new value. Now, the difference in this equation is the fact that we have different interest rates for different years, especially the third year. So we can now modify this equation as this. So this is now the original value times 1 plus the first year's rate, so let's call this R1, times the second year's rate, R2, times the third year's rate, R3, and it's now going to equal a new value. Well, all we can do now is literally put in everything we know. So we know that the original value was $6,000, so it's going to be 6,000 times 1 plus the first year's rate. Well, 1.5%, guys, if you put that in your calculator, that's basically the same as 0.015. If you got the percentage button, you could actually write directly. So essentially, 1 plus that is just 1.015. Again, the second is the same, 1.015. However, the third year we don't know. Let's just call it 1 plus r, yeah? And it's going to now equal the total of 6,311.16. Okay, so This isn't as bad as it looks, I'm not gonna lie. All you gotta do is literally rearrange this to make R the subject, and you're done. Now to do this, what I personally recommend is that you could go ahead and smash all of these three in the calculator if you want, and whatever you get here, let's just call it answer for now. We're gonna now divide this across to the right hand side, yeah? So we're now gonna get 1 plus R equals 6,311.16 over your answer, right? And then whatever this is now, you're going to now subtract it by 1 to get R the subject. So R equals all of this minus 1. And when you do that, you should get a value of 0.021, which is actually the same as 2.1%. And that's it, guys. You're literally done. Alright, guys, number 12. Alright, so it says that a total of 80 men and women took part in a race. Now, a cumulative frequency graph gives information about the times in minutes they took for the race. Okay, so breaking this down, we can see that across the horizontal axis that this is all the minutes they spent. And on the vertical, we got the cumulative frequency for all the adults combined, yeah? So just to understand it clearly, we can say that for the first 10 adults, they spent about 31.5 minutes in a race, so they're quite quick. Whereas if you include every single adult, all 80 of them, then the longest they possibly could have taken was 70 minutes. Okay, so this is probably the slowest of the group, I think, depending on the question, I guess. Now, A, use the graph to find an estimate for the interquartile range. Okay, so interquartile range means the difference between the upper quartile, so Q3, minus the lower quartile, Q1. So the upper quartile here, to calculate, well, we know there's 80 people. The first quarter is pretty much means you divide it by 4. So the first quarter of this group. Well, 80 divided by 4 is 20. So we're talking about here. And that's going to be over here. So we can see that the first quarter lies somewhere here, which translates to about 38 minutes. So that's your LQ. As for the upper quartile, that's pretty much the third quartile. Well, 3/4 of 80 is 60. So it's going to be here. And then again, that translates to about somewhere over here, which shoots down to 56. So that's your, what's it called, your upper quartile. So the interquartile range is just the difference between 56 and 38. So 56 minus 38 should give us 18 minutes. And yeah, that's this part done. And for part B, it tells us that 60% of the men took 50 minutes or less for the race, whereas no women took 50 minutes or less. Okay, so just looking at this information, we can see that over here, no women were part of this group, but only men were here. And in fact, 60% of all the men were here. So just looking up at the 50 mark, just to see where it hits around here, which actually counts for 42 people of that population. And remember, all of these guys are men, so actually 60% of all men represent 42. So we can say that 42 men actually accounts to 60% of all the men. So technically, if you want to find 100%, well, you can easily just find 10% first. So dividing that by 6 will give us 7 men. And then to find the whole cohort, which is 100% of the men population, that gives us 70 men. Okay, so let's see what the question actually wants. B, work out an estimate for the number of men who took part in this. Okay, I guess we did it. The answer would be 70 men. Yeah, so actually we actually did the question. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.